Hi everyone, I hope you are doing good. Myself Ramraj B, Assistant Professor, Department of EEE from Nanda Engineering College. Today, in this video, we are going to see the types of DC generator. Right? The basic type of DC generator are DC shunt, DC series, and DC common generators. Right? But based on the excitation, the generator can be again classified into, based on the excitation, the generator can be again classified into types of DC generator. Based on excitation, the first classification is separately excited DC generator, and second one, self excited DC generator. This self excited DC generator is again classified into three different types. The first one is DC shunt, second one is DC series, and third one is DC compound. Right? So these three types is classified under self-excited DC generator. So the basic concept behind excitation, right? So the basic concept behind excitation is, the meaning excitation itself shows the type, right? What it is going to do, right? So excitation means we are going to excite something by some means, right? For example, if you want to move some particle or move some object from one place to another place, we need to apply some kind of external force. External force may be of kind of pressure, heat, light, whatever it may be, right? Any kind of energy, any kind of external energy can be applied to move that particular object, to move from one place to another place, or to displace it from one place to another place, right? It is known as excitation. Similarly, in DC machines or in DC generator or in DC motor, water or in alternator, whatever it may be, we need to excite a coil, right? We will be exciting a coil, or we need to excite a coil for the smooth operation of the particular device, right? So here we are going to have two coils in DC generator. One is field coil. One will be field coil. The another will be armature coil. I will go to next slide. One is field coil. The another one is armature coil, right? So in DC generator, I will be always exciting this field coil. And I will be operating this armature coil, or I will be exciting this armature coil with the help of prime mover. The prime mover may be of turbine. It may be classified into hydro turbine, steam turbine, wind turbine, etc. Right? This prime mover we will be using in our laboratory as motor. We will be using motor as a prime mover to operate or to excite this armature coil, right? So field coil is excited by separate DC supply. A field coil is excited by separate DC supply, and an armature coil is connected to a prime mover, then it is known as separately excited DC generator, right? In this type of DC generator, the field coil, whenever the field coil is excited through some external means or through the DC supply, it will get magnetized or energized, and it will create a flux, magnetic flux, and the armature coil is already wound on the rotor, and the rotor is rotated by the prime mover by some means. So by residual magnetism, the armature coil will have some amount of flux in it. We have already excited the field coil through the external DC supply or through separator or an exciter, right? Now the field coil will have more number of flux because it is energized, and now the armature coil is in motion. It is already having minimum amount of flux. Now the field coil and the armature coil flux, both the flux will be getting linked to each other, which will create a force, which will create some force. The force is named as EMF. The force is named as EMF, electromotive force, right? So this is the basic of principle of operation behind DC separately excited generator, right? Where the DC separately excited generator has separate excitation in field coil, and the rotor has the armature coil, which is getting rotated by the prime mover. But in self excitation, the armature itself produce the flux, or the armature itself gets energized, and with the help of the armature flux or the EMF produced in the armature, the field winding will be, or the field coil will be energized, and the produced EMF or the generated EMF will be delivered to the loop, right? So now I will explain the separately excited generator with the help of circuit diagram, right? It will be easier to understand when we see the concept with the help of circuit diagram. So this is the field coil. This is F and this is FF or F1, F2, whatever it may be. This is the current IF, which is field current. The polarity is plus, minus. So I am going to excite this with the help of another DC supply or by exciter. Right? Here I am going to have my armature winding. So this is generator and this is armature winding ends A and A or A1, A2. And this is the generated EMF EG, and the arrow mark indicates the direction of voltage, and this is the current IA, I sub X, which is armature current, which will be delivered to the load. Right? And the current is IL here. IL. IA will be delivered to the load, which is more or less equal. IA and IL are equal. Now look at here. I have given a separate DC supply, and the DC supply is connected to the field winding. This field winding is excited by this separate DC supply when the field winding is excited, when the supply is turned on, the current IF will be flow through this field winding. IF will be flowing through this field winding. Now the coil gets energized. Energized means nothing but the coil will be turned into electromagnet, right? So the coil get energized and the flux lines will be created around this field coil, right? Which will be linking with the armature winding. The flux which is produced in the field winding will be linking with the armature winding, whereas armature winding will have a residual magnetism through which it will have some flux, a few amount of flux. Now the field winding flux is getting induced in the armature winding, and this principle is nothing but a mutual induction principle. Now the field winding flux and the armature winding residual flux will link each other, and a new flux will be created in armature winding. It will get more number of flux, and field flux and armature flux linkages will be more and more. Now it will create some force in the air gap between the field winding and the armature winding, which will result in producing energy called EG, which is generated EMF. EMF will be generated, right? So you should keep in mind that we are exciting this field winding with the help of exciter, right? So the generator voltage EMF will produce a current IA. IA is the current which will be flowing in the armature conductors, and this IA will be supplied to the load. IA is the current which will be supplied to the load, whereas it is connected in series with the load is connected in series with the armature winding. So the current IA is equal to IL. So this is the basic principle behind, or the operation behind, separately excited DC generator.